Yeah, Euler is a romantic name, right? I don't know why the boss chose the name actually, but I think it's a good name. We hope Open Euler great as Euler, and Euler or Euler or I'm not sure what's the accurate pronunciation for Euler. I will use Euler. So the name is we bring new opportunity to the diversity computing era, but it's the wrong name. I should add diversified computing and AI era. I will mention this later. Okay, so first of all, I will mention a lot of times. I need to mention again that OpenEuler is an open source project incubated and operated by the Open Atomic Foundation. It's a pure foundation project. In China, there are let me calculate, there are over 1,400 company members have joined into the community and construct community together. And we have several big members which has donated money, right, to raise money, to make the project to real run as a pure foundation model. So that is, I think that is the first, in my memory, I think the first project, first in China that we really run a project like a foundation model. So that is the, I want to mention again. So for technical side, I think OpenEuler has three kind of character. The first one is diversifying computing. The second one is all scenario. The third one is AI. So that is three, I think, very specific features or slogan for OpenEuler. First, let's mention the diversified and all scenario. For OpenEuler, I think, maybe it's wrong, but I think it is the worldwide OS platform which can support the most widely hardware architecture. We support ARM64, we support x86, we support RISC-V, and we also support Power. And there are another two architecture which is only known in China, which is the first one, SW64, and another is the Long Arc. It's not famous out of China, but in China, they also used in some industry areas. So for those architecture, we have released the RTS, I mean commercial level product release is ARM64 and x86. For RISC-V, the OpenEuler supported very well. The whole RISC-V version has the same code base with ARM and x86. And then for Long Arc and SW64, we also have released we call the preview version. For Power, it's still under the construction. I think by this year we will release the standard, the commercial level release for. So all of the chipset, I mean mainstream chipset, you can find in the market. OpenEuler support them all. So that is we mentioned the diversified computing. For this all scenario, it's really a puzzled word that when we talk about all scenario, a lot of people question how can one OS to support a different scenario. It's quite easy to answer because OpenEuler is not one OS. Actually, it's a platform which create OS. So we create server, we create cloud image, we create add version, we create embedded version. So we made a system tool which is called Euler Maker. So the system share the same code base. For example, they share the same kernel version. They share the same GCC, glibc. So if we make the customer, we make the developer or the company, student can have the power to customize your own system. So that is when we mentioned the all scenario, it means you can do the OS for your scenario. So that is the scenario. Okay, so this is a rough process for the Euler maker. I guess somebody may be familiar with the Yocto. It's a little bit like Yocto, but we simplify it. So it can have different layers, and you can use the YAML file. We use YAML to describe different layer, different component. And then we can have the package build and put them together, and you can input your requirement. So according to your requirement, and the Euler maker will use those kind of bunch of YAML file to create the image. And after you create the image, you also can use the tool to customize something. For example, some files or some configuration or something like that. So that is the rough process for the Euler maker. So it has been released, so everyone can try on OpenEuler. Okay, now we're talking about AI, right? The AI is very, or AI or the heterogeneous computing, they are maybe mixed, used by the industry. For OpenEuler, we do a lot of job for the heterogeneous computing. For example, we have converted memory. We have the technology, we call it GMEM, which can connect different memory into a big memory pool from the different devices. So, and also we have converged scheduler. So that means we can make the scheduler to schedule the task among the TPU, GPU, CPU, or different kind of PU. So that is a unified scheduler. And then we try to make a converged management. That means if you guys are familiar with one API or something CUDA, we also try to build some, this kind of abstraction layer for different software for the developer to easy to develop the heterogeneous computing. So that is we work with the heterogeneous computing. And then AI. We talk a lot of AI. For OpenEuler, we see AI for OS and AI for OS and OS for AI. So for AI for OS, we know Microsoft has released the Copilot, right? And Copilot has been the word that is equal to AI for everything. Also, although it's boring, but we also still use the name. We call it Euler Copilot. It is under heavy development until now, and we will release around 3 months later. We will release the 1.0 version, the first release. I just tried 2 or 3 days before, while I was still in China. They show me the screen, the demo. When they want to show me something, I should stop. I don't want you to show me. Let me to talk with him. I type something. It's okay. It's very nice. I gave some question to the Copilot. I say, find some text file from +++ directory, and then find all of the string of which contain ABC, and then change the string from ABC to CBA. I think it's complicated enough, right? It's lucky. The answer is very nice. A very long shell script. If you use it, if you write it by yourself, although I'm very skillful in shell, but even for me, I also need to use some time to do that. Try it, but it helps a lot. So that is the Copilot we are doing. So for OpenEuler, we think that the AI will change a lot for the human being to communicate with the machine. Also, it will change the behavior the communication behavior between the people with the operating system. So that is also the way we trying to do. Anyway, no matter what I said, just wait 2 or 3 months, we will see how OpenEuler looks like. So that is the first one, we call it a Copilot. The second one, we have developed a lot of AI tools. For example, the Attune, AOps. Attune is to use AI method to do the performance tuning. It has been well deployed in China. In a lot of customers use it to promote the performance to reduce the human beings cost. And also we are developing the AOps. We also want to try to use the AI to reduce the ops cost. So it's a very complicated project. It including several projects gathered to be a big package for AOps. So they're all open source. So welcome to OpenEuler to find them and try them. And so that is for AI for OS. Another direction is OS for AI. So OS for AI is we try to make the AI is training, right? Training is very, very important job and consume a lot of resources and time and money. And so I think for OS, what we do is to help to speed up the training speed and also to save the cost to enhance the reliability, right? For this, we do some very deep study and implementation for that. For example, I mentioned GMAM. GMAM is a very good way to reduce the training time. For typical scenario, it can reduce 30 to 40% of the time. So it's very, I think, a good result. And also, besides this, another very easy, not easy, I think the common way is we need to integrate all of the famous AI stack on top of OpenEuler. Until now, we can do is one is Intel. Intel will integrate OpenAI totally on top of OpenEuler. And the second one, we also try to move, for example, the Mathball, PyTorch, TensorFlow, everything, those are the AI stack on top of OpenEuler. So we will release all of the job, also the same time for Copilot in the same day. We will hold the day. We will have the OpenEuler Developer Day event in May 30 and 31. So on that event, we will release the Copilot, and also we will release the AI stack, full stack. So welcome to to look at this event. Okay, so here is the scope and the innovation we have done during the 3 days. Some of the number maybe a lot of outage. For daily active developer, as I remembered, it's over 4,000 per day. In the beginning, very beginning, every day is only 200 or 300, but now every day there are over 4,200 developers per day. So that's a very good, I think, a very active community. And I don't read them one by one. Totally speaking, in China, OpenEuler is the biggest community. I think including every different kind of community, I think this is the biggest open source and technical community. We have a lot of newly set up projects. Okay, here is, the number is also wrong. We have over 1,400 community members. They are all Chinese famous company, big company, and also a lot of international companies, including Intel and AMD, Lenovo, a lot of companies like this. And we have accumulated over 4.5 million installation of the system, the machine, the bare metal machine. It's a huge number. In last year, I remember there are around 1.8 million bare metal installation. So that will take over 37% of the market share. I mean, newly growth market. So it's a very big achievement we have done in the latest 3 years. So this is also the first time that in China we overcome other competitors. For example, Red Hat. For a long time, Red Hat is the top vendor, OS vendor in Chinese market. But last year, OpenEuler is the first, is the ranking one. So that is good news for us. And also, we have a lot of innovation. I just list some of the innovation projects, but actually we have accumulated over 400 projects. Those projects cover the ops, embedded, robot, and AI, and cloud native, something like that. So you can go to, and we also released the white paper. We choose around 57 very I think a good project to introduce to us to the people, and it has the English version, so you can download it and to try it. Okay, I don't read them one by one. I just take someone. The first one is Esola. It's a very lightweight container engine. You can compare it with the Docker, but much faster and lighter than Docker. And also, here's the number. I don't read them. I don't read them, but you can say start time, the memory consumption, much better than Docker. And also we have the Stradivert. It's you can consider a replacement for the Qumil. It's also faster and lighter than Qumil. Here the Kube OS. It's similar, not similar for architectural level. It's quite different, but for the idea or the target we want to achieve is very similar with the Core OS or Retro OS. And also it has been widely deployed in some cloud in China, some big cloud vendor in China. And maybe next big release, we will focus on this kind of delivery way for OpenEuler. Okay, here is I mentioned we focus on not only for the cloud server, but also the embedded and the edge computing. Here is the very interesting architecture we designed for the general embedded system. But Dr. Ren will explain it in details, but save time. Every time you spend 2 hours to do explanation, right? Here we only have 20 minutes. So I just mentioned here, we have very good architecture for embedded system, very good. Okay, here is the end of my speech. A very rough introduction of OpenEuler. This is the first time for OpenEuler to came to MWC, right? In the beginning, we tried to maybe talk with Open Tom Foundation if we can set up a booth in WMC. It's too expensive, right? Too expensive, but I hope maybe in the near future we can have a booth and have even bigger stage for OpenEuler. So I strongly believe that OpenEuler will be one of the biggest community and OS platform of the world, and we with the world, for the world, to the world. So together, to grow with the world together. Okay, that's my speech. Thank you.